Hey everyone, Mr. Alex here. Welcome to my channel. In this video, you're going to learn about rate of reaction part 1. Before we start the lesson, here's the overview of this learning video. Well, when we're talking about the rate, which just refers to the speed with which the reactants get turned into the products, including all the factors which affect the rate during the chemical reactions and how the particles are behaving, which refers to the collision theories and the amount of energy needed to produce the products. And we will also see how we can measure this rate and how to show it on the graphs, like this. Okay, let's just jump right into the first part of this lesson, which is calculating the rates of the reactions. First though, it's worth understanding just how much the rate of reaction can vary. For slow reaction, think of a rusting of iron, which can take years or decades. For a typical rate, something like ripening of fruits or just reaction between magnesium and hydrochloric acid, which produces a gentle stream of hydrogen bubbles. And the other extreme, we have explosions like fireworks, which take place in just a fraction of a second. In order to actually measure the rate of reaction though, we need to either measure how fast the reactants are being used up, alternatively how fast the products are being formed. Because the faster the rate, the faster the reactants will be used up and turned into products. So in the form of equations, we have two options, either using the mean rate of reactions equals the quantity of reactants used over the time, or using the mean rate of reaction equal to quantity of products formed over the time. The quantity of the reactants or products can be measured by the mass in grams or by the volume in centimeter cubes. And the units of the rate of reactions may be given as gram per second or centimeter cube per second. So this is the example of the setup to determine the rate of the reaction of calcium carbonate and hydrochloric acid. In this experiment, you can either calculating the mass of the calcium carbonate reduces or the volume of the carbon dioxide produced as the product. How do you know the numbers though? Yes, as you know, if you are using the mass of the reactants, of course you are using a balance to see how much gram is the calcium carbonate being used up, or using a syringe to measure the volume of carbon dioxide produced. And here is the worked example of a question. Worked example number 1. 25 centimeter cubes of carbon dioxide was given off in the first 2 seconds of reaction. Calculate the mean rate of reaction and give the units. In here, what you have to do is to see what you're going to use. Is it the volume or the gram? In this one, 25 centimeter cube is indicating the volume of the carbon dioxide. So you're using the products over the time. So what you're going to write is mean rate of reaction equals to quantity of products formed over the time. By looking at the quantity of the product formed, which is the volume, which is 25 centimeter cubes in there, and divide it by 2 seconds. By using the calculator, you will get the number of 12.5 centimeter cube per second. Make sure the unit is important. You have to write the unit properly. Worked example number 2. The above reaction was carried out again. The new results showed that 2 decimeter cube of carbon dioxide was released in 200 seconds. Calculate the mean of the reaction in mole per second. This question is involving the previous knowledge about stoichiometry about the calculation of the mole in a gas. So as you have learned, 1 mole of gas occupies 24 decimeter cubes at STP, standard temperature and pressure. So in here you have to find the mole first. The mole of carbon dioxide is 2 decimeter cubes over 24 decimeter cubes equals 0.83 moles. So once you find the moles, you have to divide it with the seconds. It's as simple as that. So what you're going to write is like this. 0.83 moles over 200 seconds equal to 0.0042 mole per second. This is very easy. That's how you calculate the rate of reactions. So if you see in the graph on the right, so you will see the slope A will have a greater rate of reaction as it is steeper than the slope B. Okay, that's it for the first part of our lesson, which is calculating the rates of reactions. Now it is my time to ask you questions to see or to check whether you are paying attention or not. So let's see the questions. Question number 1. State 2 ways of finding the rate of reactions. I'll give you 5 seconds. If you need more time, you can just pause the video. Okay, the answer is by measuring the quantity of reactant used or the product formed. Did you get it correct? Awesome! So let's go to the number 2. State 2 units of rate of reaction. If you can state 3. The answer is gram per second, centimeter cube per second, and mole per second. Question number 3. State 2 ways of measuring the quantity of reactant or product. The answer is mass in grams and volume in centimeter cubes. Good job! Number 4. A student carries out an experiment reacting hydrochloric acid with a calcium carbonate to give calcium chloride, carbon dioxide, and water. Write the balance symbol equation for this reaction. I believe you still remember how to balance a chemical reaction because this is very important. The answer is, and don't forget to put the state like calcium carbonate, solid, hydrochloric acid, aqueous. There's those kind of states that you have to fill in, and then also the balancing. Good job, everyone. Number 5. The student collects 50 centimeter cube of carbon dioxide gas in 10 seconds. What is the rate of the reaction? Include the units. If you need time, you can just pause the video. The answer is 5 centimeter cube per second. Make sure you follow how to answer it properly, including the units properly.